Hi everyone! Have you ever wondered something? The water that you drink, the ice and the vapor all have the exact same molecular formula, which is of course H2O, but they feel so different from each other. Well, the answer lies in the atomic placement. So in today's video, we're going to unwrap this mystery of atomic placement and in detail discuss about what exactly is the solid state of matter. But let's start from the basic. What do you think is matter? Anything that has mass and occupies space is called matter. Well, there goes the definition of matter. But in reality, everything around you, even if you don't see it, the air, do you see it? I don't think so. But it's actually matter. So this matter that I'm talking about exists in three different states, which is solids, liquids, and the gaseous state. Well, these three different states of matter are quite interconvertible to each other. Solids can convert to liquids via melting, liquids convert to gases via evaporation, gases can convert back into liquids via condensation, and liquids convert to solids via solidification. Now the question is, how do we differentiate between these three different states of matter? Well, any matter which you see around you is made up of its constituent particles. These constituent particles can be atoms, molecules, or ions. The answer is the arrangement. The arrangement of these constituent particles is the main differentiating factor. So if you look at the solid state of matter, these constituent particles in solids are very closely packed and they are not at all free to move, and they can only vibrate about their mean positions. This further confers the solids properties like rigidity, non-fluidity, constant shape, and constant volume. Talking about the liquid state, these constituent particles in liquids are comparatively more free to move, but they still touch each other, because of which liquids are not rigid. They are fluid, they do not have a fixed shape, but they do have a fixed volume. And if we talk about the gaseous state, the particles in the gaseous state are far apart from each other, not even remotely in contact, because of which the gases are very much fluid, not at all rigid, they do not have a fixed shape, and definitely not a fixed volume. Now let me ask you a very simple question. What do you think happens when gases are heated at very high temperatures? Well, if you think that gases become hot, think again. When gases are heated at very high temperatures, they undergo something called ionization. In ionization, atoms are converted into ions, into positive and negative charges, which are called cations and anions. This is the very secret fourth state of matter, which is called the plasma state of matter. The plasma state of matter has a gaseous mixture of cations and anions, and it is conducting, unlike the gaseous state. So now we know about not just three, but the four states of matter, which is solids, liquids, gases, and the plasma state of matter. To conclude what all we have just studied, that we know matter actually exists in three different states, three main I would say. Fourth is the plasma one, which we just discussed, okay? But the three different states are quite interconvertible, as we discussed, and solids can convert to liquids, as you can see, via melting, okay, and the process can be repeated from liquids to solids via freezing. Then again, liquids can convert to gases via evaporation, and the process can be to and fro from gases to liquids via condensation. The gases can also convert to solids via deposition, and the process can be repeated from solids to gases via sublimation. So this is something which is quite well a summary of what we have to discuss in the next, let's say, 10-15 minutes, okay? So we will talk about each of these steps in detail. So let's start. Okay, so if I talk about melting, okay, in melting, as we know that a solid, I'm taking example of ice, of water, okay, is converting into your liquid, okay? So this happens when we are heating the solid, okay? So when the temperature is going to increase, okay, this is what a solid looks like. As we already discussed, in solids, the particles are quite close to each other, and because of that, the motion is not very high, okay, a very random little motion they have. But the kinetic energy is still there, okay? So when we are heating the solids, the kinetic energy of the particles tends to increase, okay, and the bonds between the different particles tends to break, okay, and that is when your solids are converting into liquids, okay, and this process, as you know, is called melting, okay. So the temperature at which this happens, the conversion of your solids to liquids, is called the melting point of a solid, and that is of course different for different solids, okay. All right. Moving on, as you know, that when you convert a solid to a liquid, as I already said, you have to apply certain heat energy. Okay, you have to heat the solid for to convert it into a liquid. This is something which we usually know. But what you will notice is that, let's say you have a sample of solid, okay, and you are heating it, okay, you are constantly heating it, and you are trying to convert it into a liquid form, okay, into a liquid. But if you measure the temperature of this solid, okay, when the process of heating is going on, okay, even at that time, the temperature of, let's say, ice, let's say I'm talking about ice and I'm heating ice and I want the ice to convert into liquid, okay. So if I measure the temperature of this ice when it is being heated, the temperature is not going to increase, okay. Even we are supplying the heat, we are heating the sample, okay, we are heating ice, okay, physically we are applying certain amount of heat, even still the temperature is not going to increase. Why? Where is the heat going? We are supplying heat, right? But the heat is not heating up the sample, it's not heating up the ice, okay. This heat is actually used up, okay, in breaking the bonds between the solids to make it convert into liquid, okay. So that's why this heat which we are supplying for the solid to convert into liquid is not actually used for raising the temperature of the solid, but is used in breaking the bonds, okay. That's why you don't see any increase in temperature, breaking the bonds. And because you don't see any increase in temperature, so bond breaking is a process that you cannot see, right? But it is actually happening. That's where the energy is being used. But since with your eyes you cannot see the change in the increase in temperature, that is why this heat that we supply to solid for making it convert into a liquid is called the latent heat. Latent means hidden, okay. So since we do not see where that heat is going, okay, because we do not see an increase in temperature, but we know that something, the heat is definitely going, that heat is called the latent heat. And since the process is conversion of solid into liquid, this will be called the latent heat of fusion, okay. All right, I hope we understand why the word latent has been used here. All right, now we talk about boiling. So we know that your liquids also convert to gases if we keep on further heating them. So as we just discussed, we had a solid, okay, which is ice, and we started heating the solid and it finally converted into a liquid, okay. When the process was going on, the temperature was not increasing, even though we were supplying it the amount of heat that we were, okay, because that heat was being used somewhere else, that is breaking of bonds, okay. And that was called latent heat. Well, that's what we have understood as of now. But when we further keep on heating the liquid that we have, okay, then these bonds are going to further break, okay, and that is when they're going to convert into gases. Is that clear? So this is a very, very important process of conversion of your, using heat as a medium to convert your different solids, liquids, and gases, into each other. Is that correct? All right. Again, similarly, on the same lines, we have latent heat of evaporation or boiling. Here, I will say this is not evaporation, but boiling. So as you are increasing the temperature, so this pot of water is being heated, okay, and if you measure the temperature, this water is not going to be at 100 degrees Celsius, because even though we are supplying heat, that heat is being used up in breaking of bonds and not to increase the temperature of this boiling water, okay. So that is why if somebody asks you a question, in fact NCERT is asking you a question, that what causes more severe burns, steam or boiling water? Well, steam is what happens or what is formed after the conversion has already taken place, okay, the conversion of solids to gases, and that is why the steam is definitely going to be at 100 degrees Celsius. But as we discussed, the water is not going to increase its temperature unless and until the process of boiling is going to complete, and that is why it is going to be less than 100 degrees Celsius, okay. That is why more severe burns will be caused by steam and not with boiling water, okay. So I hope we are clear with what is latent heat of boiling and latent heat of fusion. All right, moving on, we have since we just discussed about temperature causes change in the state, okay. We started from a solid, we heated it, we got a liquid, we further heated it, we got a gas. But is only temperature something which can do this? Can we also do the same thing by applying pressure? Or what effect does pressure have? Let's understand for a while, okay? So as you can see, we have these particles in this, okay, in this container. So as and when we apply a high amount of pressure, okay, this pressure is going to make these particles come even further together. And when that happens, okay, this causes, particles to be together, and conversion of them from gas to liquid to further your solids. Okay, so basically our main idea is to have particles together. So different ways we can do that. If we are doing that with the help of pressure, that's also okay, right? But the main idea is to bring the particles together in case of solid, and far apart in case of your gases, okay, and little closer in case of your liquids. So the same thing pressure can also have. As we apply pressure, as the pressure increases, okay, it becomes more and more, or the process of solidification begins. All right. So similarly, I hope you understand what is dry ice. Okay, dry ice is actually your solid carbon dioxide. It's nothing but your solid carbon dioxide, and this actually is something which converts directly into gases. So as we know, we have learned that solids, they first convert to liquids, which further converts to gases. Okay, and we have the different process names for that. But this dry ice is something which does not believe in going to this liquid stage, and it directly converts from solid to gases, and this process is called sublimation. Okay, it's a very important process, and I hope you guys remember the name of this. So this happens in case of dry ice, and you can see how this dry ice is being converted from solid state directly to the gaseous state, and that is called sublimation. All right, moving on, we have, so well, this is the effect of temperature. So now let's talk about evaporation. Well, we have understood what is boiling. Okay, in case of boiling, we have the sample is going to be heated. We are applying heat from outside and making the temperature increase, and that's when the sample is going to convert into gas. Okay, but is that necessary? Us making the effort and giving it heat, is that necessary? Well, no. Why? Because in this case, as you can see, if you just leave some quantity of water, it's very high temperature. Let's say you live in, a tropical region where the temperature is quite high, and if you leave a glass of water on your table for more than, let's say, 5 or 6 hours, you won't even see it because it will be evaporated. Okay, so you didn't supply any heat, by yourself or deliberately, but still it actually got away, okay, or it got converted into the vapor form. That process is called evaporation. In this also, the liquid is converting into gas, but we are not putting any effort from our side. It happens on its own. Okay, and that is something evaporation is about. So if you very carefully notice, this evaporation actually is a surface phenomena. Okay, so you can see that the surface molecules, in case of boiling, all the molecules, the bulk molecules are heated, and they are converting into gaseous form. But in case of evaporation, because it is not something which we are doing, we are deliberately providing certain energy. In this case, only the surface molecules which are on the surface, okay, they are getting enough energy and from their surroundings, and they are being evaporated. Okay, that is why it's a process which is not something which we are initiating. It is happening on its own. Okay, and that is why it is a surface phenomena. So this word, that it is a surface phenomena, is very, very important, and you have to memorize this word. Okay, all right, not the word, but you have to memorize the concept of it being a surface phenomena. All right, so I think this is something which we all have seen. Okay, washing the clothes and drying them up outside. Okay, I think everybody has used this and seen this somewhere or the other. Okay, well, the answer is that in this way also, we are just doing nothing, but our clothes are wet, and after, let's say, 2 or 3 hours, depending on the weather also, they are dry. Okay, so this also is nothing but evaporation. Our clothes are wet, but the water content that they have is, it goes away after a while, and this, we are not heating this, we are not heating our shirts, are we? No, but still it goes away. This is nothing but a very good example of evaporation. Okay, and now we have to understand that this evaporation actually depends on certain factors. If I talk about these factors, the first and the most important one is increase in surface area. So as I've already discussed, it is a surface phenomena, right? So more the surface area we have, the high amount of evaporation will take place. So that is why we are advised to spread our clothes and then hang them around, and not just without spreading them, because spreading them will increase the surface area and will also increase their tendency to evaporate. Okay. Second one is, so the increase in surface area has been done. Second is an increase in temperature. So of course, it's quite visible to all of us that these clothes are easily, they easily dry up in hot weather conditions. Like in summers, it's very easy to dry up the clothes, but in winters, well, it takes hours. Okay, it takes days sometimes. So yeah, increase in temperature, again a very important factor for evaporation, because, well, the thing is, right, we have to convert the liquid state into solid, into gaseous state, and heat is going to work. Heat is our friend, right? Okay. Next is a decrease in humidity. So I think you all will agree to the fact if I say that in monsoon, drying of clothes is something which is, my god, it's a pain in the, okay. The reason is that in case of humidity, because when it's humidity, water vapor, the air around us, or not around us but around the clothes, has water vapor. Okay, and because it has water vapor already in the air, that is why the water which comes out of your t-shirt or your shirt is not ready to escape from your shirt. Okay, because the water vapor is already there in your surroundings, and that is why in case of your humid conditions, it is difficult for the clothes to dry. Okay, and the last one is an increase in wind speed. So what will wind speed do? It's very easy phenomena that in case of a windy day, the clothes will very easily dry up. Okay, the reason is that in case of wind, what happens is this wind is just, trying to take away all the water vapor which is present near your shirt. Okay, and that is why the water molecules which are going to come out of your shirt are will easily escape out. Okay, which is something which was not happening in case of your humidity. Okay, in case of humidity, the water vapor which was present in the air was already surrounding your shirt, and that is why what water molecules which are present inside your shirt were not able to come out. Okay, but that does not happen on a windy day. In case of a windy day, the water molecules present inside the air will just, swoop out, and your shirt will be easily able to dry up. Okay, so now we have to talk about a small difference. So of course we noticed that liquids convert to gases, and this can happen via two ways. It can happen via evaporation, or it can happen via boiling. Okay, but then what is the difference? As I already said, boiling is something which we deliberately do. We supply the heat, and it's a bulk process. So you can see all the molecules in the bulk are going to be heated at the same time, and of course are going to evaporate out. But that does not happen in case of evaporation, where not all the molecules but only the surface molecules will be taking up enough energy from the environment and will convert into your gaseous state. Okay, so, well, this is a very simple explanation of your different states of matter. Okay, and their interconversions to each other, and the effect of temperature and pressure on the, well, conversions to each other. Okay, so I hope you guys liked and understood whatever I spoke about in this video. If you do that, then please visit EduRev and practice the test, read the notes, and, well, that's going to be good for you guys. Okay, so thank you so much for watching, and stay tuned for more.